Hello, everybody. Here we are, 5.2. We're looking at like terms and unlike terms. And the notes for this is just that you can combine like terms. It's kind of just like same terms to simplify polynomials. Okay, so I think basically what we're going to unpack in this lesson is this phrase like terms. So what are like terms? We're going to look at some things that aren't like terms, and then ultimately what is a like term. And it's really important in math. You see this word simplify often, and it means what it means anywhere else, that you are just going to make things simpler by combining things. You're not going to have a bunch of terms. You can reduce the number of terms by combining the ones that are the same. So let's look at some criteria right here. So an example, 4x and 3, these are not like terms because the second term has no variable. Okay, so this 3 right here does not have a variable, or you could think about it, maybe it does have a kind of invisible one to the power of 0, but we'll get into why that doesn't really get us anywhere either. So these are not like terms. Because 3 is a constant, it does not have a variable beside it, so these two are not alike. The next one, we got 4x and 3y. Okay, these both have variables. However, they are not like terms because the second term now has a variable, but it doesn't match the variable of the first term. Okay, so it seems like so far we need to have both have a variable or else both not have a variable. And they need to be the same variable. So here we got an x, we got a y, but these are not like terms because they have different variables. Last one, we got 4x and 3x squared. Okay, so they're both a variable. They're both x's. However, these are still not like terms because the second term now has the same variable, but the degree is different. Remember, the degree was, this one's going to have an invisible 1 there. So we have to the power of 2 and we have to the power of 1. It's not the same degree, so these are not like terms. And finally, 4x and 3x, these are like terms. Now the variable is the same and the degrees match as well. So, similarly, we could have 4x squared and 3x squared. Okay, same variable x and same degree 2. So it doesn't just need to be just an x on its own. It could even be, 4 and 3. It just needs to have the same variable and the same degree. And those can be different variables and they can be different degrees. So let's do some examples. Hopefully that'll help us. From the list, identify the terms that are like 3w squared right here. Explain how you know they are like terms. Okay, so this negative 5w, it does have a w, so it has the same variable. However, it's not the same degree. We have a degree of 2, and here we have a degree of 1, so that's going to be a no for us. Next, we have negative 6w squared. Okay, so we have the same variable, and we have the same degree, so that is going to be a match. Let's make that a green, and we'll circle it. Oh, that's not green. There we go. So that's a yes. We have the same variable, the w, and the same exponent, the 2. Next, we have just a 2 on its own, or negative 2 actually. This one doesn't have a variable, doesn't have the same degree, so that's a no. Next, we have 4w. Similar to our negative 5w, we have the same variable, but we don't have the same degree. This one would have an invisible 1 right there. And 1 is not 2, so that is not the same. Next, we have 3w squared. Again, we got the w squared, same variable, same degree. So these are like. So that's a yes. Okay, next is a negative w squared. Yeah, this also has a w, a same variable, same degree. So this is like as well. Next, we have 11w, same variable, not the same degree. And finally, 2, same coefficient, essentially, same number up front. though it doesn't have a variable, it doesn't have a degree, so that's a no. So, I mean, how do you know, explain how they're like terms? I think I said that verbally, but I'm going to say they all have the same variable and the same degree. And I'm going to add something here just as an aside or a note here. They do not need the same coefficient. So you notice this one has a 2 as a coefficient, this one has a -6, this one has a 3, this one has a -1. They don't need the same coefficient to be like terms. It's the variable and the degree of the variable that matters. So I think that's important to note. I would love it if you write that down on your notes. So next, let's combine like terms to simplify. And this is what I was talking about, is just making it easier to look at. I like to, can be a visual person. So I'm just going to circle the like terms. We have this +4, we have this +1, and we have this +1. And let me do this one. We have this, so put a triangle around the plus x and another triangle around the plus 5x. Now we can rewrite this. This is a 4 plus 1 plus 1 plus x plus 5x. Now let's combine these ones and combine these ones. These ones are all like terms. They are constants. We can add them all up. 4 plus 1 plus 1 is 6. And next we have x and 5x. Those are like terms. They have the same variable to the same degree, so we can add those up. Remember, there's an invisible 1 right here beside this x. So we can add those to plus 6x. If we we're going to write this in standard form, we would have it as 6x plus 6. So in descending order of our variables, but you really don't need to. Next, let's look, let's examine this one, I guess. I mean, we have a -3y squared, we have a +3y, and we have a -2. There's no like terms, so that's as simple as it's going to get. We can just leave that one as it is. Let's do the next one. Okay, here we have, we've got 2x squared, put a triangle. We have a -4x squared, and we have a +5x squared. And in the middle, we have a +8, and we have a -11. So let's rewrite that. 2x squared subtract 4x squared plus 5x squared plus 8, subtract 11. And now let's look at our individual parts. Let's look at all of these like terms, and then we can look at these like terms. So 2 subtract 4, that's going to be a -2. And then plus 5 is going to end up with a +3x squared. And then 8 subtract 11 is going to leave us with -3. And let's do the next one. I was going to show you, eventually maybe I'll show you one with algebra tiles, but maybe I'll show it down here. So just so that you know how to do both, and so that I'm not forgetting about our beloved algebra tiles. Okay, let's do another one. We've got a 3y. That's a y squared. Okay, we got a -y here, -2y there, and no more like terms. Here we have a +y squared and a -3y squared. And finally, we have that +1 tucked in there. So now I'm going to rewrite this with our terms together. I'm going to put our y squareds first. So 7y squared subtract 3y squared plus 3y subtract y subtract 2y plus 1. Okay, let's see. Now we're going to look at these like terms. Oops, I went a bit too far. Those like terms. And this set of like terms and this one are constant at the end. So we have 11y squared subtract 3y squared. So that's going to leave us with 4y squared. 3y subtract 1y subtract 2. Well, that's just going to be 0. So there's going to be no y's left. And let's not forget our constant, the 1 left over. So that's our answer for that one, 4y squared plus 1. Okay, for the next one, identify the equivalent polynomials, justify your response. So let's look first. We need to examine whether or not they have any like terms for us to combine. This one we have a negative 5y squared, a negative 3y, and a negative 4. So no like terms for us to combine, actually. Similar to B, we have a 10x and we have a negative 1. No like terms for us to combine. C, we have a 1, we have an x, we have an x squared. So again, neither of these, nor A, B, or C, have like terms for us to combine. So I'm actually going to draw these out. Let's do, so we're looking for 5 negative y squared. So remember our squares are going to look like this. And they would be shaded in because they're negative. And we have 3 of our negative y's. And we had 4 negative 1's. Let's do B. We have 10 of those x's. They're positive. A lot to draw. This is the downside of algebra tiles. But as you know, I'm trying to be open. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 negative 1. Let me draw C. We have a positive 1. We have a positive x. And we have a negative x squared. Okay, now let's look at combining. We do have like terms in D, so let's look at combining those. So D, we have the 2y squared, a negative y squared. Those are our two like terms there. So positive 2y, let me rewrite this. Negative 7y squared plus 2y squared. And then we have a negative 3y. That's that one. And then we have a negative 4, a negative 16, and a positive 16. Okay, let's do it. This equals negative 7 plus 2 is going to be a negative 5y squared. Next, we have the negative 3y, and we have a negative 16 and a positive 16. That's going to cancel each other out, and we're left with that negative 4. Okay, so looks like this one here, negative 5 y squared, negative 3y, and a positive or negative 4. So I'm going to say D here is the same as A. Let's do E. Let's gather our like terms. We've got a 12x, we've got a negative 7x, we've got a positive 5x. So let's go 12x, subtract 7x, plus 5x. And then we have our negative 7, negative 8, a positive 14. So let's go subtract 7, subtract 8, plus 14. And now let's just add these up. I'm going to add it up over here. 12x subtract 7 is going to be 5x. And 5x plus 5x is 10x. And next we have Negative 7 subtract 8 is negative 15, plus 14 is going to be negative 1. So that looks like here we got our 10x's. We have our negative 1, so this is going to be the same as e